Okay, alright, here we are again with more equilibrium questions. So we got hydrazine, nitrogen, and hydrogen all in equilibrium at a certain temperature, and we have these concentrations that are initially present. So we need to figure this out using an ice table. The equilibrium constant can only be figured out from equilibrium concentrations, not initial concentrations. So let's go ahead and set this up. Initially, we have 1.2 molarity of the hydrazine. We have 1.0 molar hydrogen, and we have none of the nitrogen. And we're going to have some differences here in x. Remember, we put the plus under the 0, so there's going to be plus x here and plus 2x. And this can be minus x. And we add the columns. Well, hold on. This right here is the equilibrium concentration of nitrogen. So the equilibrium concentration of nitrogen is 0.8. Okay? Add these columns, 1.2 minus x. Add these columns. This will be 1.0 plus 2x. And then what we're going to do is use this information to tell us what x is. Okay, 0 plus something is equal to 0.8. So x is given to us indirectly here by this column. So 1.2 minus 0.8 is equal to 0.40, right? If we do that correctly to the, tenths place, 0.4 I mean. And then 1.0 plus 2 times 0.8 should be equal to 2.16, right? Yeah, 2.6, okay? Now we know concentrations here of equilibrium concentrations, and we can go ahead and plug this into an equilibrium expression. So we have to create that. KEQ is products over reactants, nitrogen, hydrogen, squared, don't forget the 2's, right? There's our 2, divided by hydrazine, okay? And we'll plug these in here. Nitrogen is 0.8. Hydrogen is 2.6. 2.6, and we're going to square that guy. And hydrogen is 0.4. All right, and we're going to get 0.8 times 2.6 squared equals, divided by 0.4, 13.52, okay? Now we want to round this off to 2 sig figs, so that rounds off to 14, and that would be this first choice here on my quiz.